Hi, it's Jocelyn, and I'm about to do Advent of Code Day 11. Alright, so just a few numbers this time. Dumb octopus. Alright, so these are octopus levels, energy levels. Oh, this is a really long one, okay. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Okay. So just because the example is so long. Alright. How many total flashes are there after 10 steps? So if one flashes, then then that raises the ones beside it by 1, and those can also flash, and so on. Okay, yeah, let's do this. So for C in input, in line dot chars dot enumerate, that's an X position. We also have our Y positions. If this looks similar, it's because this is also a grid. So I'm just going to call these oct for octopuses, is a hash map, and it is mutable. So now we have octopus.insert, same coordinate system as last time, and then the character to digit dot unwrap. Alright, and now we have parsed our map. So it says that there are 100 steps. So for step in 0 to 99, we're going to flash the octopuses. Oh yeah, right, this needs to be base 10. Okay. So this is best done recursively because there's two ways of doing it. There's one way is to keep on doing it until there are none to continue flashing, and alternatively we can do it recursively. I'm just trying to understand. Okay, so just trying to understand how, I want to make sure I get the cascading behavior right. Okay, so we have to do it recursively because any octopus that flashed during this step has its energy level to set to 0, regardless of how much above 9 it went. Okay. Let's try just one first. So this is just 10 by 10. So for Y in 0 to 9 and for X in 0 to 9, we're going to try flashing this. So for, let's see. And that's the case where it flashes. To flash, it goes in, we do all the directions around it. So for the directions in let's see. So we have actually, yeah, this is going to be easier to do. Okay, so we have above, we have below, we have left, we have right, and then we have the diagonals. So that's everything except that's everything that's not 0, 0. So you could also, I guess, do a for loop and just exclude 2 for loops and exclude 0, 0. That would also work. Okay, so in that case, this would also go up by 1. But this could cause a cascade, which is why we're going to do this recursively. So we're going to make a function called flash, which takes our octopuses, and then it takes the position to flash at. That's just this logic. Okay, and we're removing this because this is when we're already flashing. And I'm putting that back over here. Cannot be dereferenced. Confused about that. Is that because we're using an at mute or like immutable reference? I32, right, we changed these. All right. Oh, that's for when we have get. I32. Let's see. Cannot assign to data in an index of collections. Oh, I guess we're doing this. There's probably a way of fixing that, but I'm not sure if there's a cleaner way. That needs to be unwrapped, I guess, too. So usually we use entries. Okay, and also this can be none as well. So And then unfortunately this is exactly the same. And actually I'm just going to clean this up right now. We can use, it's annoying that I have to keep on changing this in 2 places. That's okay. And same deal over here. Has overflowed its stack. Okay, so that's for, that's not a good sign. Oh, we're not cleaning them up, right, of course. So after we've done our flashes, then what we're going to, after we've done all, it just if it's equals 10, because if it's already flashed, we don't want to reflash, I guess. And then also, once we're done, we're just going to reset those all to 0. So the way that's going to work is just like this. These are always set, that's okay. Anyway, I want to run the example. In the example, after 100 steps, there are 1656 flashes. So when we're flashing, we need to count the number of flashes that happen. So that's going to be a U64. Alright, so a flash happened just from this being called, and it can happen from all of the other ones around it too. We're counting the number of flashes, and now we're counting the total number of flashes. Alright, this is a bit of a mess. And this is the U64. Okay, so we got our answer wrong here. So I just want to see what our input looks like at the end of the first step, just to see if there's anything obvious here. So that's going to, we're going to just print what it looks like. So just for the first one, so if I equals 0, oh, how'd that happen? Let's see if that changes anything. That happened a few times from copying pasting. Probably a Vim there's some Vim shortcut that insert decrements numbers. I wonder if I press that. It still wasn't it though. Okay, so it looks vaguely right, but the first step doesn't have any flashes, it looks like. So let's print the first two steps. Of course, so I see that numbers that should be 0 are actually 1, and that's because we only need to clear the flashes after all the flashes have processed. So I misunderstood that about cascading, it looks like. And now I get the correct answer. Wonderful. So let's see what the output is. Okay. How much do you want to bet this is the right answer? That much. Okay. That was convoluted, but we got it. Okay, it seems like the individual flashes aren't bright enough to navigate. However, you have a better option. The flashes seem to be synchronizing. First step during which all octopuses flash. Okay, so I have just a feeling that this is going to be a really large number, and there's two possibilities. The first is that rest and release mode is going to save us, but the more likely scenario is that there's going to be some cleverness that we have to do. I can't think of anything yet. Okay. So we're going to assume everything's synchronized, and if we have a value that is not 0 at the end, then isSync will be false, and if isSync, then we return I, and this is unreachable. Okay, so we have an example. Part B in our example, looks like that's 195. It looks like despite that going on forever, I might need to actually say this is unreachable. When do I rest configure that out? And this is irrelevant now. Right, and I guess it wants the it wants it to be 1 indexed. So we could do +1, or we could start counting from 1. I think we should start counting from 1. And we don't care about the number of flashes anymore. Okay, so I'm just going to, I guess, try this while I start thinking about thinking about how we can make this more efficient. I really can't think of a good way because, oh, actually, well, we just have an answer. Is it really that easy? It really is that easy. Okay, I was really expecting the worst there. Especially because it was like, usually it's a bit harder on weekend days and we're getting to day 10, but no, this was actually not too bad at all, except for all of my self-inflicted stupid mistakes. Anyway, thanks for watching, and I will see you soon.